Okay, so I'll switch off my camera as well. And yeah, so we were just revising what we had done, and then we'll do some problems in this space. Um, just give me a second. Okay. Um, Yeah, so we were discussing the last class. What we covered is the standard representation of a straight line, which is y equal to mx plus b, and we discussed that if the lines are perpendicular to each other, which is this sign, then the um, m1, m2, which is these two coefficients of x, will be minus 1, and if they are parallel, then M1 will be equal to M2. So that's one thing that we discussed. And we did these kind of problems where what is the slope of a line passing through? You've been given 2 points and you are required to derive the um, slope. And as we saw in the previous slide, the wording slope or tangent or tan theta or m, they remain same. They can be used interchangeably, so don't get confused if sometimes you hear slope, sometimes you hear tangent, sometimes you hear tan theta or gradient. So all of them are same. And we discussed that the slope or gradient or tangent will be equal to rise over run. Some pitfalls of this calculation, we discussed that if you just be very careful about x2 minus x1 and y2 minus y1. uh, so that was one. We did some more problems related to this. Yeah, again, uh, just you have to be very careful about how you're calculating the tangent. Another problem, a tricky one, but I think Elizabeth or somebody solved it in a different way. We also looked at the proof of that theorem of m1 m2 equal to minus 1. So I don't know if you were able to do you guys did you get time to look at this proof, or do you think you can prove this on your own? If you have not, I'll still suggest that take some time and see if you can independently prove it. Um, if you can, it will give you a very solid understanding of algebra and very solid understanding of coordinate geometry. So we did that proof M1, M2, and we also did a proof for um, M1 equal to M2 if the lines are parallel to each other. We looked at the distance formula as well between 2 points, and then we did um, some questions related to uh, yeah, some questions related to these ramps and where our understanding of this line really came into picture. So that was what was covered in the last class. If you don't have any questions as such, then we can move on and let's try to do some basic revision of this, of the concepts that we learned, and then we'll go from there. Okay, so this is one question. See, what do you think about it? Okay, everybody solved it. Ansh, how about you?
I solved it as well.
Okay, so these have become very easy for you now. There's no point in asking easy questions in the class. So let's do some tricky ones, which some of us got wrong earlier. Okay, let's look at this question pretty much on similar lines. What do you think? Okay. Sorry, guys, I didn't notice that you're marking answers now. Can you mark it below the line, the marker I've created one? Below this, please. Again, if you have just. Okay, I have two different answers this time. Aaron, your answer was B, is it? Uday, you think it's A? How about you, Yugala? Okay. Yugala, you think it's C. And Uday and Ansh, you think it is A. All right. And Aaron, how about you?
I think it's B.
You think it's B? Okay. So, um, who can explain to who is feeling very confident about their answers? Yugala, Ansh, Uday, Aaron. Which one of you is like extremely confident that that's the answer? Uday, can you explain?
I'm actually not feeling too confident about my answer.
Okay, that's all right. Uh, Aaron, Yugala.
So I think it's C because like I got the points for each of the like dots and then I just put it in the equation and C works for both of them. I tried to.
Oh, that's clever. So, for example, which point? This and this point. So this point
That
between
one and the one above it.
this point in 1 0, and this is 0 1. Yeah, that's clever. But but you know what this question is asking you is, if you notice, the black line seems to be parallel to the red line. Do you agree?
Yep.
the black line is seems to be parallel to the red line. What is the relationship if the two lines are parallel? What is the relationship of their gradients? Aaron, do you remember what's the relationship between gradients?
It's the same.
It is same, which
Yeah.
means if the first equation is equal to y equal to minus of x plus 3, or in this case m is equal to how much? What is m, do you think?
Minus x.
Why?
Negative of 1.
Negative 1.
Negative of 1, because the formula for a straight line is y equal to mx plus b, right? That's the formula.
Yeah.
That's the standard representation of a straight line. So m is equal to minus 1, which means the gradient for even the black line will be the same. Now, if you look at this gradient for this line's gradient, the first line, which is y equal to x plus 3, the gradient for that line is 1, which means this line is nothing but perpendicular to red line. It will be somewhere, I don't know where, but it will be perpendicular to the red line. The second one, again, gradient is 1, which means it is going to be perpendicular. Do you get it? Why it will be perpendicular? What will be the angle line A or line B or line C? Line A, B, and D, they will make against, actually, B and D are same, right?
Oh
So
yeah.
what is the angle they will make against red line?
90 degrees.
90 degrees, because M1, M2 equal to minus 1, right? For perpendicular lines. So that's what this question was trying to ask. And if you look at it, um, yeah, if you look at it, then this is the only one where the gradient is negative. So it is x equal to 1 minus y, and this, and I can't deal with this equation in this format, so I'm going to change this into the into the standard format. So I'll keep y at one side, so I'll bring y to the left side and I'll take x to the other side, so it will become negative of x plus 1, which means that this line and this line, both of them have the same gradient, which means they're parallel to each other. Other three lines are perpendicular to the red line. Okay.
Yep.
All right. So this is one question we got wrong. There's one more question we got wrong. Let's look at that as well. Aaron and Ansh and Yugala, I don't know. Have you done this test? There was a paper on your classroom by the name Y9 G and E 001 graph and linear equation.
Yeah, I did.
Okay. Aaron, you
Yes,
should
sir.
also try that.
Okay.
It'll give you a very good understanding of linear equations. Although I think, yeah, I mean, let's do this one as well. I'll just grab a jacket. Just give me a second. One of the things that Yugla did in the last question was also pretty interesting, right? If you don't know anything, just find some numbers and see which one matches. Find some numbers and see which one matches. D matches because plus one at the end means plus one above the origin. Sorry, I didn't get that point.
Wait, like, can you see that it's the top point, right? It's 1 0. No, it's 0 1. So it's so if so it's something. So it'll be y equals something plus 1. It's positive, so it's above the origin, not below the origin. So it can't be A or B. And C is division, so it can't be that either. So it's D.
What do you mean above the origin? What is above the origin? Or the y-intercept is above the origin? Is that what you're saying?
Yeah, the 0 0 1 0, that the point 0.
Do you guys agree with that logic?
This.
Aaron, you gonna put that?
Not entirely. I just chose the one that matched um 0 1, and then it looked believable for whatever the x-intercept was. No, the y-intercept was.
Because Ansh, the line could also be like this, no? Anyway, so you will pick up 2 points and you can try to substitute it, see if it matches. You will um, get your answer. All right. So there was one more question that we got wrong. Um, that is this one. Let's look at this question as well. What is positive gradient? Okay. Um, Everyone thinks it is B, which is what is positive gradient? Y increases at X increases. Okay. Yeah. Okay. All right. Okay. So I think we are good overall with this. Um, what we are going to do is we will move forward on the next topic, and on the similar ones, we will continue doing. Okay, on the similar line, we will continue doing some more things. So, um, in your class, one of the common usage of this linear equation that you will find is modeling. Is modeling a scenario on using a linear equation. So we will try to do some. I think you will be able to. I think you should be able to do um, linear modeling anyways on your own. But we will try. We'll learn some bit of some examples of linear modeling in different books and different syllabus. You would find this example by different names. So somewhere you would see this called linear modeling, or you could say you could like some books could say um, oh sorry, just give me a second, my Jamboard. Some books could say for example um, constant rate of change and modeling constant rate of change, etc., etc., etc. So we'll look at some of these and then see if you can understand. um, let's look at a very like a straightforward question. Looks like to me it looks like a straightforward one, but I don't know. Let's give it a try, see what you think about this. And can you also write the linear? So there are two parts to this question, not just solving, but also writing a linear equation. That's one, and this is the second one. Yeah, let's look at these two. What do you think? Taxi charges base fare of this plus. Okay. Okay, same with you. How about you, Ansh? And all right. Okay, you understand this modeling pretty well. Then let's do one or two more. And are you also able to write the equation? So y equal to 600x. All right, good one. So those are, let's let's do one more modeling. Or am I wasting time with you guys on modeling? You guys seem to know it pretty well. You never know. Sometimes we catch something, right? Two, what was the car's speed limit? And three, these are the three questions you got to solve. Okay. Everybody got it? Same thing, is it? Aaron, how about you? Are you already typed your answer or no?
Yeah, I got the same thing as well.
Okay. All right. So looks like I'm wasting time with you on modeling. Okay. So you understand linear modeling pretty well. I will try to give you a test paper on linear modeling and make it, a little more complex so you can practice um, you can practice this a little bit. Um, Now let's try to understand in coordinate geometry, um, as far as line geometry is concerned and line graphs is concerned, there's not much that you have to now learn. So there are just a few more patterns that we will learn today, okay? And see if you can um, apply what you have, what you already know, and if you're able to solve this. So take for example, this is a question. How would you solve this? Okay, I'll tell you, you can use, you can think of those 2 points. In the last class, we discussed something called distance formula. Use distance formula and see if you can solve this. Lambda. That symbol is called lambda. It's a very famous symbol in computer science and maths. So you have alpha, then you have beta, then you have gamma, then you have delta, gamma, delta, and then you have lambda. Alpha, beta, gamma, delta, lambda. Then you have more symbols: phi, psi, theta, kappa, and pi. Well, but you don't need to know all this. Whenever you come across a symbol, just take it as a symbol. Alpha, beta, gamma, delta, and lambda are sufficient enough to give us enough tension. Okay, anyone? Yugala, Aaron, you there? Any ideas? How would you solve this?
Not really.
Okay, who can
Yeah.
remind me of the distance formula?
Isn't it like y equals x formula? It's
Yeah,
uh, it's it's a d. So distance equals square root of x2 minus x1 whole squared plus y2 minus y1 whole squared.
so this is 0, 0, um, and 3 root 3. So let's say 1, 2, 3, 1, 2, 3. So 3 root 3 here, and then 3 lambda. So these are um, 3 and lambda. Let's say these form equilateral triangle, right? Oh no, it won't be there. It won't be in that direction. Sorry, it looks like, oops, 3 root 3. Although I don't need to really know the diagram, right? I just need to, it is an equilateral triangle. Okay, it is 0, 0. It is 3 root 3. And this is x and y. So I've got to find out the the value. Oh, sorry, it is 3 and lambda, right? So x equal to 3, 3 and lambda. So like, what do you think? What comes to mind if it is an equilateral triangle? If you are able to draw the diagram, does something make sense? Does something come to mind? Yugla, Aaron? No? Hello, guys.
I'm not sure.
Okay. So if you're not sure about it, what does this question tell you? Like, what does the question tell you? What is the relationship between these 3 points, A, B, and C?
They're all at 60-degree angles to each other.
Yes, and what? I will share with you some more, one slide from the last class that we did. Can you see my screen? Guys, can you see my screen?
Yeah.
Yeah. Okay.
Yes.
Now, what we were discussing in this is in coordinate geometry, if there are 2 points between, A and C are 2 points, and x1, x2 is the coordinate, x1, y1 is the coordinate of A, and x2, y2 is the coordinate of C. And we wanted to find out the distance between any 2 points. The formula of how do we find the distance. So look at what we did here, right? We created a triangle, imaginary triangle here. We said, okay, AB will be equal to x1, x2 minus x1, because this distance, this distance is x2, and this distance is x1. So this part, which is equal to this part, is equal to x2 minus x1. Similarly, this part is equal to y2 minus y1. And then we used the Pythagoras theorem to say that, okay, because this is base is this x2 minus x1, perpendicular is y2 minus y1, and therefore from Pythagoras theorem, AC will be the square root of adjacent square plus perpendicular square. Okay, so distance between any 2 points is always calculated using this. Remember this formula, right? Y2 minus y1 whole square plus x2 minus x1 whole square. That's how we calculate the distance between any 2 points. Now, if you want to apply this here in this problem, how would you apply this? Or take for example, I give you another problem, right? almost of the similar type, right? Let's look at one more problem. If the distance between point 4p and 10 is 5, then p is equal to. So can somebody, does it click to somebody? How would you solve these two problems using the distance formula? Yes, everyone.
Yeah.
How? What do you think? What should I do?
So since the distance between 4p and 10.
Yeah,
Wait, so is this for like the question or like the triangle?
anyone. Pick any
Okay,
question. Yeah, pick
I'm
any question.
taking the 4p one.
All right. Yeah.
So you establish you establish 5 as the hypotenuse of this triangle,
Okay.
say,
Yeah.
and
Look,
wait, now I'm
the way to look at it is, okay. We will do this again one more time, and then we will solve these two problems one by one, and then we will solve some more problems, okay, related to this. In coordinate geometry, whenever you have 2 points, right, wherever, point 1 and point 2, x1, y1, and let's say x2, y2, right? And the distance formula, which is how much is the distance between these 2 points. And think about it, right? Like there are so many applications of this problem. uh, like for example, uh, this is a distance time graph of a car. Okay. Car was here at x1 y1, and then like somewhere sometime later it reached x2 y2. How much distance did it travel? Something like that. What was the speed? Something like that. So there are many practical application of this concept that you can find. Okay, but today's class is mostly understanding the distance formula, so we'll just do that. Okay, the distance is a straight line distance between these 2 points, right? So this value, let's call them a, b, c, right? And then let's draw them towards the coordinate geometry, end of coordinate geometry. Ansh, I'm like, you should remember this, Ansh. We have done this in the class as well, okay? In earlier classes as well, with you as well. So now if you look at this, AB, what is the value of AB, Yugala, you think? Or tell me the points. So I will mark 4 points, right? Point number 1, point number 2, point number 3, point number 4. The 4 people, you guys are going to tell me the coordinates of these 4 points. Who wants to go first? Aaron, tell me the coordinate of first point.
Uh, Point C is 1 3.
Sorry,
Wait, what are you
The-
asking?
I'm asking the coordinates of point 1, which is marked by this cross, this point.
Oh, 10.
No, it's not 1. 1
What?
is the number, right? Oh, sorry. A, let's call it A. Oh, sorry.
Oh,
I don't know what to. These numbers are not, yeah, this is just the name. The only thing given to you is this. The coordinate of C1 is given to you, which is x1,
ah,
y1. Coordinate of A is given to you, which is x2, y2. So you have to find out all four, those of 1, 2, 3, 4 points. So what is the coordinate of point number 1?
X0,
X10 or X0?
X0,
Okay, why would it be X0?
because it's the x-intercept.
So you're saying this one is X0?
Yes.
Okay. Do you guys agree, Uday, Yugala, Ansh?
Yeah.
Yep.
Okay,
Yeah.
so if you agree, what is the coordinate of point number 2?
X2 comma 0.
X20, yes. So if either Yugala, if you are correct right now, then Aaron is not correct because Aaron is saying it is X0. You're saying it is X20. So what do you think should be the coordinate of 1? Or you correct yourself? Uday, what's the coordinate of point number 3?
Wouldn't it be 0y?
0, y. Okay. And what's the coordinate of 0, 4? Like point number 4, Ansh? Hello, guys. Ansh, what's the coordinate of point number 4?
Um, it's something Y. Um, um, it's is it X
See,
two
if the
Y?
coordinate of C is x1, y1, if this is x1, y1, then this one has to be x1, 0, and this one has to be 0, y1.
That's Y2
This
or
one,
zero
like point
Y2?
number 3, has to be 0, y1. So what
Oh,
should be the point number 4?
zero Y2.
0, y2. And what is point number 2? x2, 0,
Yeah, so X
isn't it?
two Y. Oh, I see.
Do you get my point, guys? Like x1, y1, if if I change the diagram a little bit, okay, if I change the diagram a little bit and I say that, okay, there is this point which is 3, 4, okay, if I draw a perpendicular from here and here, can you tell me what will be the coordinate of this point? Like this is, let's say, point number A, and this is point number B. What is the coordinate of point number A and point number B? What's the coordinate of point A? Aaron?
30.
3, 0. Do you guys agree, Yugala, Uday, Ansh?
Yeah.
And what's the point of what's the coordinate of B, Uday?
04.
0, 4. Yes. Because it is essentially representing how high, what is the rise and what is the run, right? That's what the 3 and 4 point represent. So if this is 3, 4, and let's say this point is 6 and 5, right? I will join these 2 points. This is point um, P1 and this is point P2. And if I draw this line and I say B, And here I say, oh, not B is already there. So I'll name something, let's say Q, and I name this R. Okay, because this point is B already named. Okay, so what is the length of AQ, do you think? What is the length of AQ? Yugala, Aaron, Ansh?
2.
2.
Okay, why do you think it is 2? What is the coordinate of Q, Yugala?
5, comma 0.
Are you sure it is 50? Do you guys agree? It is 5. Yugala is saying this is 50.
Sorry, 60.
60, because
So
you,
it's 3.
so it's 3, correct, right? What is the length of BR? What is this? What's the measurement of BR? Aaron?
Is it 1?
1, because it is 0, 5, right? So you see, you are intuitively, if it is number, you are intuitively subtracting y2 minus y1 and x2 minus x1, isn't it? That's what you're doing. So all I have done, I'll change the perspective now a little bit, okay? And I'll draw another diagram now, this time with red, okay? So now I have a red triangle. I have a red triangle, okay? And let's call this red triangle this time, whatever, X. Oh, sorry, I already have P1, P2, and let's call this P3. Can you guys tell me what is the size of P1, P2? Type it out. Calculate P1, P2. Okay, you think it is root 10. All right. Uday. Okay, Aaron, you also think it is root 10. Ansh and Uday.
Root 10.
Okay. So you know how to do this, right? The distance formula. This is exactly what you have done. Okay. Distance P1, P2 equal to square root of square root of 5 minus 4 whole square plus 6 minus 3 whole square. That's what you have done, right? Or has somebody done something different to find the length? I'm just generalizing what you have done. Yugala, Ansh, Uday, Aaron.
Yeah, that's what I did.
Uday and Ansh and Aaron, do you guys also agree? This is what you have mentally done. You might have just calculated 5 minus 4 equal to 1, and you know 6 minus 3 equal to 3, and then square rooted 1 to go to the Pythagoras theorem. But ultimately, if I want to generalize, this is what you have done, right? Now, if you look at it, essentially, if this is this point, if this point, I'll use a different color this time. If this point is x2, y2, and this point is x1, y1, all you have done is to find distance between 2 points, y2 minus y1 whole square plus x2 minus x1 whole square. Do you agree? Look
Yeah.
at exactly what you have done. Y2
Yeah.
minus y1 whole square plus x2 minus x1 whole square, right? That's what you have to remember. In coordinate geometry, if you have been given the coordinates of two different points, the distance between those 2 points is this. This is the formula for distance. Is this clear, everyone?
Yeah.
Always y2 minus y1 whole square plus x1 minus x2 minus x1 whole square. Now, if we go back to the previous slide, look, this is what I was trying to do here. Okay. And I was just going to say a, AB in this slide, AB equal to y2 minus y1 and BC is equal to x2 minus x1. And therefore, AC equal to square root of AB square plus BC square, which is AC equal to y2 minus y1 whole square plus x2 minus x1 whole square. Clear, everyone? Is the same formula. All right. So if you know this now let's look back at the problem statement given. So let's solve the bottom problem first. The distance between the points 4P and 10 is 5. Then P equal to what? This will include your understanding of quadratic as well as this. I think so. So I'm going to pick this up and I'm going to put this on the next slide. Then we'll solve. Okay, Aaron, you think it is A? I'm going to paste it here. Yeah. Okay. What do you think, everyone? Eh, Uday, you got A, is it?
Yeah.
Ansh and Yugala? So the distance between 2 points will be y2 minus y1, which is 0 minus p whole square or p minus 0 whole square, whatever, right? Plus x2 minus x1 whole square, 1 minus 4 whole square equal to 25. That's my theorem. So that gives me p square plus 9 equal to 25. That gives me p square is equal to 16, which when solved gives me p equal to plus minus 4. Right? Very simple solution. Okay, now let's look at another problem which we didn't do it the last time, or we couldn't do it earlier. This is the problem. 3 points 0 0, this and this form an equilateral triangle. Then lambda equal to what? What are the properties of equilateral triangle?
All the sides are equal and all the
All the
angles are 60
60.
degrees.
So yeah, so angle is none of our interest in this case. Although you can use the angle to solve this as well, but that's not our interest right now. So we'll just focus on the distance formula. So try using the distance formula, see if you can solve it. Okay, Ansh, you got A. Okay, anyone else? Ansh, do you want to recheck your answer? Okay, Uday, you think D. All right. Can you explain why D? Aaron, you think it is A. Why? Oh, sorry. Aaron, you also got D later on. Okay, can someone explain to me? Hello, guys. Can someone explain to me? Please, please, I want to cover one more thing, and that is going to be concluding your coordinate geometry. All right. It's root, it's root minus, it's negative root 3. All right. How did you solve it? What's your answer, Aaron? Uday?
Yeah, I also got minus root 3.
How?
First, I found the distance between 0, 0 and 3 root 3,
So that will be, oh,
2 root 3.
that will be 3 minus 0 whole square plus root 3 minus 0 whole square. That is the distance. And then the distance between the lambda point, is it? 3 minus
Yeah,
0 whole square plus lambda minus 0 whole square. Like that.
yeah.
So this gets cancelled. So this is 3 equal to lambda square, which gives you what? Lambda equal to?
Root 3. But um, it has to be negative, so it's minus root 3.
Why does it have to be negative?
Based on the point, it makes an equilateral triangle.
Superb, wonderful. Otherwise, it will be the same point, right? So actually,
Yep.
the value you are getting is plus minus root 3, but it can't be root 3 because root 3 is already one of the vertices. So it has to be negative of root 3. Wonderful. Very well done. Okay, guys. I'm glad that you are able to solve this problem. Very good. Very nice. There is one more thing I want to discuss with you, okay? And that should conclude your large part of coordinate geometry. Okay. Now, between 2 points on a Cartesian plane, on a Cartesian plane, find the oops, coordinates of midpoint between 2 points x1, y1 and x2, y2. You've been given 2 points, x1, y1 and x2, y2. You have to find the coordinate of the midpoint between these 2 points.
Is the midpoint x2 minus x1 over 2 and y2 minus y1 over 2?
Type it out and think carefully. Okay. Aaron thinks it is x1, x2 minus x1 by 2, y2 minus y1 by 2. I'm assuming you are saying in bracket x2 minus x1 whole divided by 2 and y2 minus y1 whole divided by 2, right, Aaron? Yeah. All right, cool. Okay, Aaron, you got it. And are you fully sure that this is what it is? This is, are you absolutely sure?
Yeah, I'd say so.
All right. I'll just request you again to look at it. Very basic pitfalls, right? These are very basic things. I'll draw the diagram, you will understand. So I'll suggest you take a look at it again and think again. Yugala, Aaron, Ansh, sorry, Yugala, Ansh, Uday, how about you guys? Yugala, Uday, are you and Ansh? Where are you guys with this? Should I add
One more
them instead
minute.
of subtracting them? I don't know, Aaron. You are going to tell me. What? Aaron is saying, should I add them instead of subtracting them? You can multiply them also as long as you can prove that you are right. It's a maths class, right? Okay. Yugla and Aaron, both of you seem to align on the answers. Yeah. In that case, Aaron is going to change the answer now. Uday and Ansh, what do you guys think?
Right now, I think I agree with those answers.
But they have different answers. Whose answer do you agree with?
Aaron.
You agree with Aaron's answer. Okay, let's look at it. I don't draw well. Like, give me a second. Yeah, I'll pick up the image from here, from Desmos, so I can draw them. I can draw and show you properly. Okay. All right. So this is my diagram. Oops, sorry. This is my Cartesian plane. Okay, and I'm going to draw two lines. So let's say this point, and let's say this point, right? This is 5, 3. So let's match these 2 points, this, and let's match this point. Okay. Yeah, looks a respectable diagram now. A little tricky, but yeah, it'll do the job. Although I could make it a little bit more plain. Yeah. All right. So, Aaron, do you want to explain why did you first subtract and then you added?
So I basically just found the midpoints between x2 and x1 by adding them both. Then once you divide them, you get exactly the middle. And I did the same thing with the y coordinates, y2 plus y1 divided by 2 to get the middle. And then that should be the middle of the line.
Okay, so this one is x1, this one is x2, right?
Yep.
This one is x1, this one is x2, this one is y1, this one is y2. I'm not writing the other coordinates just to save the clutter. Okay. Now, if I do x2 minus x1, if I do x2 minus x1, you gotta just watch, right? 5 minus 2, that gives me 3, isn't it? Divided by 2, that gives me 1.5. Does that anyway give me the midpoint? Yugala?
No.
No, it doesn't. So how do you derive it? The way you derive it is, what is the length of these 2 points? What is the length between these 2 points? What is the distance between these 2 points? Ansh, Mr. Ansh Patel,
X2 minus um
x2 minus
where X this is
x,
that. So
x2 minus x1, right?
yeah,
That's the
so
distance
X2
between these
minus
2 points, right? So let's take half of this, okay? Half of, so the midpoint will be somewhere here, right? So let's take half of it, right? The midpoint will be equidistant from here and equidistant from here, which means the distance from this point to this point, right? Or let's say A, B, C, right? So AB and BC have to be equal, right? AB and BC has to be equal, right? So that B is the midpoint. And because I know that AC is x2 minus x1, therefore AB and BC has to be x2 minus x1 divided by 2, or equal to AC by 2. That I'm just writing the distance. I'm not writing the coordinates. I'm writing the distance, right? Do you understand this point? This is point number A. Oh, so why do I? Yeah, look at it carefully, okay? Look at it carefully. This is point number A, this is point number B, and this is point number C. The midpoint on x-axis is B, and assuming the midpoint here on y-axis is D, let's say D, E, F, let's say. That's how the points are named, or the other way around, D, E, and F. And therefore, this point is the midpoint. So the distance between the AB, length of AB is x2 minus x1. Sorry, length of AC is equal to x2 minus x1. Therefore, AB is equal to x2 minus x1 by 2. So this point from here to here is x2 minus x1 by 2. And from here to here is also x2 minus x1 by 2. Do you guys agree, everyone? Yugala,
Yep.
Yeah.
Ansh? Yeah. And because that is the distance, so the coordinate to point B will be the distance from origin. And therefore, the distance from origin is x1, which is this, plus x2 minus x1 by 2. Now, if you simplify this, you will get x1 plus x2 by 2. That's the coordinate of B. Similarly, coordinate of E will be y2 plus y1 by 2. And therefore, the midpoint formula is x1 plus x2 by 2, y1 plus y2 by 2. Uday, Yugala, you guys, x1 plus x2 by 2 and y1 plus y2 by 2. This is a very important theorem. Is this understood, everyone?
Yeah.
All right. So now I think with this, your lessons on, I mean, we can still do more complicated coordinate geometry. We will learn more patterns in coordinate geometry. We will do more problems. But as far as your lessons in coordinate geometry is concerned, till your year 9 and 10 for a straight line is complete. Okay. All that is left now is for you guys to practice. Okay, so I will just quickly revise what we have studied in coordinate geometry. Okay, we've studied slope, gradient, right? And we've studied two relationships m1, m2 equal to -1 and m1 equal to m2 for parallel lines. Second, and we've also studied y equal to mx plus b. That's my straight line equation. We've studied the distance formula, which is y2 minus y1 square plus x2 minus x1 square, all square rooted. That's the distance formula between 2 points. We've studied the midpoint formula, which is x1 plus x2 by 2 and y1 plus y2 by 2. There is nothing else in coordinate geometry. Pythagoras theorem and this one. And beyond this, you would see in some books, there are many other formulas derived, theorems derived, which is like, you know, if there are two lines, for example, there's a line, right? This is x1 x2 sorry, x1 y1, this is x2 y2, and there is a point that divides it in the ratio of m1 into m2. How do you find the coordinate? There are so many different type of questions will be there. I don't think in your syllabus it I have never seen it getting that complicated till your year 12 mathematics. I do maths till year 12. I've not seen it getting very complicated. So all fundamental first principle formulas and first principle understanding is these three: understanding slope gradient, which is one of the absolute critical thing for you to for you in higher classes. Slope gradient, tan theta, and whatnot, and the distance formula between 2 points and midpoint formula between 2 points. And if you can prove m1 m2 equal to -1 and uh, m1 multiplied by m2 equal to -1 for perpendicular lines, and for parallel lines it is m1 equal to m2, you should be able to solve all questions in coordinate geometry. Okay, any questions, anyone? All right,
Mm.
so what do we want to do next in the class? Do you have some preference? I wanted to pick, I think with your level of intellect, um, okay, so with your level of intellect and understanding, I think when it comes to questions where there is measurement, etc., measurement, volume, you will be able to do it. Financial mathematics also, I think you should be able to do it. I don't see that as a challenge for you, um, unless you tell me so. But I don't think you will have a challenge with financial mathematics, general equations, and with measurement and volume, etc. Where you will face problem is complex geometry and complex algebra. So I was thinking of doing algebra and making it more complex, understand polynomial, different techniques of solving polynomials. Some of it we did in the last class on Monday, but we'll do more complex polynomials and different theorems. So you get a better hang of algebra. So that's what I was thinking about. But I'm happy to adjust the way you want. Aaron, Yugala, Uday, Ansh has said anything is okay. But how about you guys? Do you have any preference for the next class?
Not really.
Okay.
Yeah, same, not really.
All right, cool. So we'll pick up algebra from the next class. Okay. And I'm going to share some practice problems on the classroom. So if you get time, try to do these coordinate geometry problems. Okay. All right. I'll see you in the next class then. Thank you very much, everyone.
Thank you.
So
Thank
thank
you.
you.
Bye.
Thank you.
Bye.